The in-tube extraction that we used for the beer analysis is a dynamic headspace extraction method. That means that we use a fraction of the headspace that we suck through a syringe or a sorbent that is packed into a syringe. The extraction then takes place by a number of so-called extraction strokes. That means we aspire and dispense the headspace fraction from the vial. So this is a general principle, and two important benefits of these methods are that, first of all, the sorbent bed is outside of the vial. That means if we use higher temperature to increase the volatility of the compounds, then our sorbent is not necessarily heating up as well, at least not as much. And secondly, in ITEX, the in-tube extraction system, we have an external heater. That means we are independent of a temperature profile of the injecting system. In this specific application for the beer analysis, we focused on aroma compounds, so volatile compounds that are making up finally the aroma of beer. We could have used other microextraction techniques as well for that purpose. So this is not a unique point for ITEX. But the advantage of the ITEX system for this application was that we very rapidly could screen a variety of different sorbents. And finally, we found that although it is less sensitive, PDMS was the best sorbent for this specific application. And the reason for that is that in beer analysis, or if you use or look at the headspace of beer samples, you have always a lot of ethanol present, of course. And therefore, you need a high capacity sampling sorbent. Otherwise, you will have sorptive competition, and that may lead to losses of compounds that are present in minor traces. So therefore, for us, the ITEX system was perfect because, as I said, we could screen quickly various sorbents and finally use a PDMS as a high capacity sampling sorbent.